So this is a series of videos that discuss several interesting mathematical problems that have a aesthetic touch. The problems can be ranging from analysis to calculus to algebra to geometry. So as the third problem, so we're gonna do problem number 3. We're gonna evaluate a special integral. So evaluate the integral 1 minus x over 1 plus x square root dx. And so we're gonna see how the math works behind. So we can start with 1 minus x over 1 plus x square root. So in this problem we're gonna do a common algebra trick here. So what we're gonna do, we're gonna multiply by the conjugate of the bottom function. So it is 1 plus x times 1 minus x. That's the conjugate of the bottom function. So we're gonna multiply the top and bottom by that, still inside. Now what's gonna happen when you simplify? You're gonna get 1 minus x squared the top. In the bottom, due to the difference of squares, it's gonna get 1 minus x squared under square root. So if you take the square root, what's gonna happen? You're gonna get 1 minus x in the top. In the bottom, it is 1 minus x squared square root, the integral dx. So yeah, so let's put the dx here again. So okay. So now what we can do, we can split the integral into two fractions. So we can have 1 over 1 minus x squared square root dx. That's the first one. And the second one is minus x over 1 minus x squared square root dx. And you can see that the first one is very easy to integrate. The second one, you know that the inside function 1 minus x squared, the derivative is a negative 2x. So we're gonna create negative 2x there, so that means we can have 1 over 1 minus x squared square root dx. And then this is, I'm gonna take the negative sign inside, so this is 1 half negative 2x over 1 minus x squared square root. Now you can see that the both functions are very easy to integrate. So the first one gonna give you sine inverse x, and the second one is just a substitution problem, because you can see that the top is the derivative of the bottom function, so you can just use the power rule. So that means you're gonna get 1 minus x to the negative 1 half, so that means the integral become 2 square root 1 minus x squared with 1 half is simply become 1 minus x squared square root plus c. So so this is how we can do this problem. So let's see whether there's another way to do this. So for example, we can use a non-traditional substitution here. For example, you can say x equal sine theta. So we can say u equal sine theta, and then du becomes cosine theta d theta. So our integral now becomes, so it is 1 minus x over 1 plus x dx. So it now becomes 1 minus sine x over 1 plus sine x. So what we can do, we can multiply by the so let's write it the integral first. So it's gonna be like that. Now what we can do is we can multiply by the conjugate of the bottom function. So it is 1 minus sine x over 1 plus sine x times 1 minus sine x, 1 minus sine x, sine theta square root times cosine theta d theta. So what's going to happen now, you can see that the top is simply 1 minus sine theta squared. The bottom is due to the difference of squares 1 minus sine square theta. Now we have the square root here and cosine theta d theta. So what we can do now is we can put the square root sign to both of those functions. So that means it's simply going to be 1 minus sine theta. So 1 minus sine theta to the top. In the bottom, 1 minus sine square theta means cosine square theta. So under square root, it simply becomes cosine theta. So with this cosine theta, so we have that, and then you can see that the cosine get cancelled. So you simply end up getting 1 minus sine theta d theta, which is very easy to integrate. So this is theta minus, so this is the sine theta, that means it plus cosine theta plus c, and then if you use the trigonometric identities, so what's going to happen, this simply becomes, the first one becomes sine inverse x, and the second one cosine theta means 1 minus sine square theta, so that means it's going to be 1 minus square root. So this is the second approach to the same problem. Thank you.